4, 6, 20 format, securing the fact that 4 times 6 is 24, and looking at the links between multiplication and division. There are 4 quadrants, and the idea is that you wouldn't do all 4 quadrants in one sitting, but would take one at a time and really dig deeper and explore each one. We're going to start with the top left-hand quadrant. So this quadrant's all about what does it look like? Different ways of representing 4 multiplied by 6 is 24. So we've got the bar model at the top left here. So here we could think about, well, what if we've got 4 parts? So if our bar model is split into 4 equal parts, then how big will each part be? Each part will need to be 6, because 6 times 4 equals 24. We could split the bar using the same number fact. We now know that 4 6 times equals 24 as well. The array is a really good model to make the commutative nature of multiplication really visible. So we can do 4 this way and 6 this way. And to build an array that has got 6 columns of 4, or we can think of it as 4 rows of 6. We can also draw it this way round. So no matter which way we draw it, we know that we've got 24 squares in the rectangle because both of them are 6 by 4. The groups image supports how 6 multiplied by 4 can be used for division. So here we've got 4 groups. So how many can we have in each group in order to use 24? So we can just do it by counting. If we don't know the fact, this is our way to devise it. And we keep going until we've used 24 dots. So 24 shared equally between 4 groups means there will be 6 in each group. The next image here gives me 6 groups. So I'm thinking about how many 4s are there in 24. So I can do, here's a group of 4, here's a group of 4, here's a group of 4, and I can keep doing groups of 4 until I've used up all 24 counters. So we can use a bead string before we do the jottings on the number line as a concrete representation. So the language of multiplication would be thinking, well, if I've got 6 groups of 4, how many beads will I use? So there's 1 group of 4, 2 groups of 4, 3 groups of 4 are 12, 4 groups of 4 are 16, 5 groups of 4 20, so there's my 6 groups of 4, showing that 6 4s equal 24. I can also use the bead string using the language of division. So there are my 24 beads. I want to do 24 divided by 4 using the language of how many groups of 4. So let's see how many groups of 4 we can make. There's 1 group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4, 6 groups of 4. So there are 6 groups of 4 in 24. The number line can also be used as a model for 4 multiplied by 6 equals 24. And we can do jumps of 4 along the number line to see how many jumps of 4 we can do to make 24. So we can see here we've got 1, 2, 3, 4, 5, 6 jumps of 4 equaling 24. Scaling uses the language of how many times bigger. So if I have a block of 6, how many times bigger will I need to make it in order for it to be equal to 24? So I know that there are 4 6s in 24, so therefore 6 needs to be made 4 times bigger in order to be equal to 24. In exactly the same way, if I want to think about how I scale up 4 to equal 24, it needs to be made 6 times bigger, because 4 times 6 equals 24. So we can see here we've got a range of models and images to support the deeper understanding of how 4, 6 and 24 are related to each other.